Welcome to Robominions.in AI interview preparation app. So the topic of this video is parenthesis matching using stack. So this is the code for implementing matching of opening and closing parentheses using a stack. So let's start tracing the code. We have a hash include stdi.h, then hash include stdlib.h, then hash include string.h. Then we have type def stack underscore struct. We have size of stack, top of stack, and stack array pointer here. Then we have renamed this struct stack underscore struct with stack. Okay, and then we have a declaration for check parenthesis matching. So this function receives the expression pointer. Then we have push operation, pop operation, which takes a stack pointer st underscore ptr and the data for push, and for pop it just takes the st underscore ptr pointer and pops the data. Then we have int main. Inside that we have a character expression pointer pointing to the string a plus b of in the bracket into c into in the bracket d by m. So then closing brackets. So then we have if check parenthesis of expression. So that expression is passed to check parenthesis match. So it goes to check parenthesis match. Then we have stack underscore dt structure. Then so the size is a string length of expression. String length of expression, that is this one, is of 16 characters. So 16 is the size. Then we have a stack array. So we allocate that size memory in the heap and create the stack. So we allocate the memory. So if you see, it goes to this struct, and size is 16. Top of stack is garbage right now, and then we have a stack underscore array allocated with 16 locations of memory. So it starts from index 0. So you need to follow this convention. It's a stack data here, index and address. So yeah. Then we have top of stack equal to -1. Then for int I equal to 0, then expression of I. So expression of 0 is, so first opening bracket. So opening bracket not equal to null character, it's true, it goes inside. If expression of I is equal to opening bracket, it is true. Then push that expression to the stack. So it goes to push operation. It checks whether the top of stack equal to size of stack -1. That is, size of stack is 16. So 16 minus 1 is 15. So -1 is not equal to 15. So it doesn't go there. It goes to the else part. Top of stack is incremented first. So it is from -1, it has turned to 0 now. Then we have a stack array of top of stack. So top of stack is 0 equal to data. So data for which was passed to the push operation was opening brackets, right? So opening bracket has been pushed into the stack. You can see here it has turned green. And it comes out of the push operation, push function. Okay, and then we have another I is incremented. Now I is A. So is expression equal to, so A is equal to opening bracket? No, false. Then else, if expression A equal to closing bracket? False. It doesn't go inside. So it comes again, I is incremented. Now I is plus. Now expression plus equal to opening bracket? False. Expression plus equal to closing bracket? False. Now I is incremented to B. Is expression B equal to closing opening bracket? False. Expression B equal to closing bracket? False. So it comes out again, I is incremented. Now I is closing bracket. So I of expression right now I is 0, 1, 2, 3 and 4. So right now I is 4. So expression equal to, that is closing bracket equal to opening bracket, it is false. Here expression is closing bracket and it matches with the closing bracket, so it is true. and we see top of stack is 0. So 0 equal to minus 1 is false. So it doesn't go inside the if condition. It goes to the pop, because now we have detected a closing bracket. So we have to pop the opening bracket from the stack. So it goes to pop. So top of stack equal to minus 1, false, it is 0. It goes to top of stack, it decrements the top of stack. So it is considered as the stack is emptied. Okay. So that is so we don't need the popped data. So that is why we are not returning any data. We are just decrementing the top of stack. So we are coming out of the pop. Then now again we are incrementing I. So one opening and closing bracket is done. Now next character is star. So now I is 5. So it is pointing to star now. So star is not equal to null, true. It goes to star expression equal to opening bracket. Star expression equal to opening bracket, false. Star expression equal to closing bracket, that is also false. Doesn't go inside any of the if conditions. I is incremented now. So it is incremented to 7. So now 7th expression is opening bracket. So 7th expression is opening bracket. If 7th expression, that is opening bracket equal to opening bracket, is true, so it goes to the push. So it pushes into the stack. So top of stack equal to size of stack minus 1. Size of stack is 16 minus 1 is 15. Top of stack is minus 1. So it doesn't go, it goes to the else part. So top of stack is incremented to 0. Then we have top of stack. So we have a stack array of 0 equal to data. So closing bracket has been added. And so we have pushed to opening bracket to the stack. We have pushed opening bracket to the stack. So top of stack is incremented and opening bracket added to the stack. Then we come out of the push function, come out of the if condition, and then I is incremented again. Now I is going to point to C. So C. So now I is incremented to I is incremented to 7. So 7, expression of 7 will be C. So C not equal to null, true. And C equal to opening bracket, false. C equal to closing bracket is also false. Doesn't go inside that. Comes out, and then again I is incremented to 8. So now 8 is star. So you can see 8th index is star. Now star is not equal to null. So star expression, expression of 8 is star. Star equal to opening bracket, false. Else star equal to closing bracket is also false. Again I is incremented to 9. So expression 9 of opening bracket. So expression of 9, it's opening bracket. So opening bracket equal to opening bracket is true. So opening bracket is pushed to the stack. Okay, now again it goes to the push here. Now we have top of stack equal to 0. 0 equal to 16 minus 1, that is 15. Now else top of stack is again incremented. So we have a second opening bracket, right? So top of stack now is 1. So 1, we have opening bracket data pushed. So we have opening bracket here. So both the opening brackets are pushed. Comes out of the push function. Then we have again I incremented. Now I is D here. I is expression of I is D. So I value is the I is 10. So expression of 10 is D. D is not equal to null. Comes to expression of 10, D equal to opening bracket is false. Else expression D equal to closing bracket is also false. So again I is incremented to 11 now. So 11 has slash, so slash not equal to null, that's true. Slash equal to opening bracket is false. Slash equal to closing bracket is also false. Now again I is incremented to 12. So now m, so m not equal to null, true. M equal to opening bracket, false. M equal to closing bracket is also false. Now I is incremented to 13. So 13 is closing bracket. Closing bracket is not equal to null, true. Closing bracket equal to opening bracket is false. So closing bracket equal to closing bracket is true. So it goes inside the if condition. So top of stack equal to -1. No, it is 1. So it is not empty. So if it had been empty, then the parenthesis would have failed. It would have not matched. But lucky that the expression has a closing bracket. And the stack is not empty. So it goes and pops the data from the stack first. Goes here. Then checks whether stack is empty. It's not. Now decrements the top of stack to 0. So that one element is been considered as removed. Okay. Then again comes, now again I is incremented. So we have I 15 now. So I is 15. So is it so again closing bracket, it's not equal to opening bracket, false. Goes to the else if closing bracket is equal to closing bracket, true. So stack is equal to -1, false, it is 0. So again pops the data, goes to the pop function. So top of stack is 0. So 0 not equal to -1. Stack is not empty. So it goes to the else part. Now top of stack is decremented again to -1. Comes out of the pop function. Then again I is incremented to 16 now. And last null character is null character not equal to null character will be false. So it comes to top of stack equal to -1. It is true. So now top of stack is empty. It indicates that all the parentheses have been matched. So the opening parentheses were added to stack. Closing parentheses removed those opening parentheses from the stack. So if the stack is empty, it means both opening and closing have matched. So then it goes and returns 1. So once 1 is returned, we have check parenthesis match of expression. So this has become turned true. So it comes parenthesis has matched. So the output we got parenthesis has matched. So this then it comes out of the check comes out of the main function. So the time complexity of this algorithm is order of n. Okay. So as there is a for loop which iterates through all the expressions of the given expression, so it is of the time complexity of the size of the expression. So order of n. Okay. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.